Ready to unlock amazing insights? This is Zentara Unlocked, your daily audio journey from Zentara.blog. Listen to a top article each day, wherever you are. For a fresh wave of knowledge, visit Zentara.blog. 6 new mind-expanding articles land every single day. 10 reasons the flat Earth theory makes no sense. Have you ever seen pictures of Earth from space? It looks like a beautiful blue and green marble, perfectly round, or more accurately, a sphere. For centuries, humans have observed the world around them, and through careful thinking and clever experiments, figured out that our home planet is indeed round. However, you might have heard some people talking about the idea that the Earth is actually flat, perhaps like a pancake or a disc. This idea is called the flat Earth theory. While it might sound interesting or different, when we look closely at how the world works and the amazing things we've discovered about space and physics, we find that the flat Earth theory just doesn't add up. It doesn't match the mountains of evidence we have collected over thousands of years. In this article, we're going to explore 10 fascinating reasons why the idea of a flat Earth doesn't make sense when compared to what we see and understand about our amazing universe. Get ready to discover some cool scientific facts that show why the Earth is definitely, wonderfully, and undeniably round. We have tons of strong evidence Earth is round, and we'll look at why flat Earth theory is wrong by exploring how we know Earth is round from different angles. Let's dive in. 1. Looking at ships sailing away shows the curvature of the Earth. Imagine you're standing on a beach, waving goodbye to a ship sailing out to sea. As the ship gets farther and farther away, something interesting happens. You don't just see it get smaller and smaller until it's a tiny dot. Instead, the bottom of the ship seems to disappear first, then the middle, and finally, the top of the mast is the last thing you see before it vanishes completely below the horizon. If the Earth were flat, the ship would just look smaller and smaller until it disappeared from view, like a car driving away on a long, straight road. But because the Earth is a sphere, the ship is sailing over the curve of the planet. It's like an ant walking over the top of an orange. The lower parts of the ant disappear behind the curve before the upper parts do. This effect, where objects disappear bottom first as they move away over the horizon, is one of the oldest and most straightforward pieces of evidence Earth is round. It clearly demonstrates the curvature of the Earth. This observation has been noted by sailors and thinkers for thousands of years, long before we had rockets or satellites. It's a simple but powerful way how we know Earth is round. 2. Seeing different stars in different places proves it. Have you ever traveled far away from home? If you have, and you looked up at the night sky, you might have noticed that the stars look a little different. For example, if you live in the northern hemisphere, like Europe or North America, you can see the North Star Polaris, which seems to stay in almost the same spot all night. But if you travel to the southern hemisphere, like Australia or South America, you can't see the North Star at all. Instead, you see different constellations and a different point in the sky around which the other stars seem to rotate. This change in the visible stars as you travel north or south is strong evidence Earth is round. Think about it like this. If the Earth were flat, everyone on that flat surface would see the exact same stars in the sky, no matter where they were standing, assuming a clear night. But because the Earth is curved, your view of the distant stars changes as you move across that curve. It's like looking at a ball. Someone standing on the top sees different things than someone standing on the bottom. This phenomenon is a key reason why flat Earth theory is wrong, and a clear demonstration of how we know Earth is round, based on celestial observations. 3. Understanding time zones shows the Earth spins as a sphere. Why is it daytime in one part of the world while it's nighttime in another? This happens because the Earth is a sphere that is constantly spinning on its axis, an imaginary line running through the North and South poles. As the Earth spins, different parts of its surface face towards the sun, getting daylight, while other parts face away, experiencing night. This is why we have different time zones around the world. If the Earth were flat and the sun shone down on it, the entire flat surface would experience sunrise and sunset at roughly the same time. There wouldn't be different time zones spread out across the world. The fact that we can call someone on the other side of the world and know they are experiencing a completely different time of day is solid evidence Earth is round and rotating. It fits perfectly with the model of a spinning sphere being lit by a distant sun, which is a fundamental concept in understanding how we know Earth is round. The existence and predictability of time zones provide a practical and undeniable reason why flat Earth theory is wrong. 4. Watching lunar eclipses reveals the Earth's shadow. A lunar eclipse is a really cool event where the Earth passes directly between the Sun and the Moon, casting a shadow on the Moon. When this happens, the Earth's shadow that falls on the Moon is always curved. No matter when or where a lunar eclipse occurs, the edge of the shadow biting into the Moon's surface is consistently a segment of a circle. Think about what kind of object would always cast a circular shadow when lit from different angles. It's a sphere. A flat object, like a disk, would cast different shaped shadows depending on the angle of the light. Sometimes a circle, sometimes an oval, sometimes even a line if viewed edge-on. The fact that the Earth's shadow during a lunar eclipse is consistently round is powerful evidence Earth is round. This observation was actually noted by ancient Greek philosophers over 2,000 years ago, and was one of the earliest scientific proofs of the Earth's spherical shape. It's a simple yet profound way how we know Earth is round. 5. Satellites and space travel only work if Earth is a sphere. Today, we rely on satellites for so many things: GPS navigation, weather forecasting, global communication, and even watching TV. These satellites orbit the Earth, constantly circling around it. This is only possible because the Earth's gravity pulls on them, keeping them in a curved path around the planet. If the Earth were flat, there would be no way for satellites to orbit it in the way they do. They would either drift off into space or just fall down. Furthermore, space agencies like NASA and others around the world regularly send rockets and spacecraft into orbit and beyond. The calculations and trajectories for these missions are based on the Earth being a sphere with a specific mass and gravitational pull. Every successful satellite launch and space mission is a practical demonstration and irrefutable evidence Earth is round. We have countless photos and videos taken from space by astronauts and satellites that clearly show our planet as a sphere. Satellites prove Earth is round beyond any reasonable doubt, providing overwhelming evidence Earth is round, and showing definitively why flat Earth theory is wrong. 6. Gravity pulls towards the center of a sphere, not just down. Gravity is the force that pulls everything towards the center of the Earth. It's what keeps our feet on the ground and stops us from floating off into space. On a spherical Earth, gravity pulls equally towards the center from all directions. This means that down is always towards the middle of the sphere, no matter where you are on the surface. If the Earth were flat, gravity would likely behave very differently. Depending on the model a flat earther uses, gravity is often explained away by other forces, or dismissed entirely. However, the way objects fall, the tides rise and fall due to the Moon's gravitational pull, and how our own weight is measured consistently around the globe, all align perfectly with the understanding of gravity acting on a sphere. Trying to explain these phenomena on a flat Earth is incredibly difficult, and requires inventing new unsupported physics. Understanding gravity explained for kids as a force pulling towards the center of a sphere is key how we know Earth is round. The consistent force of gravity everywhere on Earth is strong evidence Earth is round, and explains why flat Earth theory is wrong. 7. Traveling east or west eventually brings you back to your starting point. Imagine you start walking or flying in a perfectly straight line, always heading east. If the Earth were flat and infinite, you would just keep going east forever. If it were a flat disk with an edge, you would eventually fall off the edge. Though no flat Earth map agrees on where this edge is or what it is like. However, we know from countless journeys throughout history and today that if you travel consistently in one direction, east or west, and don't change your heading, you will eventually circle back to where you started. This is the principle behind circumnavigation, sailing or flying all the way around the world. This is only possible on a sphere. Just like walking around a ball eventually brings you back to your starting point, traveling around the curved surface of the Earth does the same. This undeniable fact of global travel is powerful evidence Earth is round, and demonstrates how we know Earth is round through exploration. It's a practical reason why flat Earth theory is wrong. 8. Different climates and seasons make sense on a tilted sphere. Why is it hot near the equator and cold near the poles? Why do we have different seasons, like summer and winter? This all makes perfect sense when we understand that the Earth is a sphere that is tilted on its axis as it orbits the Sun. The tilt means that different parts of the Earth receive more direct sunlight at different times of the year, leading to varying temperatures and seasons. The curvature of the Earth also means that sunlight hits the poles at a shallower angle, spreading the energy out and making them colder than the equator, where sunlight hits more directly. On a flat Earth, it would be very difficult to explain the dramatic differences in climate we see around the world and the consistent patterns of seasons. Sunlight would hit the entire flat surface more uniformly, or require a complex, unproven model of how the sun moves above the flat disk. The observed patterns of global climates and seasons fit perfectly with the model of a tilted, orbiting sphere, providing crucial evidence Earth is round. Understanding how the Earth's tilt and orbit interact with its spherical shape is key to how we know Earth is round and why flat Earth theory is wrong when explaining these natural phenomena. 9. The view from high altitudes shows the curve. Even without going all the way into space, you can start to see evidence Earth is round just by getting high up. Pilots flying airplanes at cruising altitude often talk about seeing the slight curve of the horizon. The higher you go, the more pronounced the curve becomes. While the effect isn't as dramatic as photos from orbit, it's still noticeable. Even using high-altitude balloons equipped with cameras, you can send them up to the edge of space and capture stunning images that show the distinct curve of the Earth against the blackness of space. If the Earth were flat, the horizon would always appear perfectly flat, no matter how high you went, assuming you could see far enough. The fact that people who ascend to significant heights consistently report and photograph the curvature of the Earth is a direct observation that supports a spherical planet and is strong evidence Earth is round. It's another piece of the puzzle that shows how we know Earth is round, and why flat Earth theory is wrong. Deset. Ancient astronomers figured it out thousands of years ago. It might surprise you to learn that the idea of a spherical Earth is not a new one based only on modern technology. In fact, educated people in ancient Greece over 2,000 years ago already understood that the Earth was a sphere. Philosophers like Aristotle observed the curved shadow of the Earth on the Moon during lunar eclipses, as mentioned in point 4, and noticed how certain stars were visible in some locations but not others, as mentioned in point 2. Another ancient Greek scholar named Eratosthenes even calculated the circumference of the Earth, how far it is around the planet, with surprising accuracy over 2,200 years ago. He did this by measuring the angle of the sun's rays in two different cities a known distance apart, at the same time of day during the summer solstice. His method relied entirely on the Earth being a sphere and the sun's rays being parallel. The fact that his calculation was close to the actual circumference is astounding, and provides powerful ancient evidence Earth is round. This shows that the understanding of a round Earth isn't a modern conspiracy, but a conclusion reached through careful observation and clever geometry centuries ago, long before modern science. This historical understanding is a strong argument for how we know Earth is round. As we've explored these 10 points, it becomes clear that the idea of a flat Earth simply doesn't align with the vast amount of evidence we have from observation, physics, space travel, and even ancient history. From the way ships disappear over the horizon to the existence of time zones, the curved shadow during a lunar eclipse, the ability of satellites to orbit, the consistent pull of gravity, the possibility of circumnavigation, the patterns of climate and seasons, the view from high altitudes, and the findings of ancient astronomers, all signs point to a spherical Earth. The evidence Earth is round is overwhelming, and comes from many different independent sources. Understanding these points helps us see why flat Earth theory is wrong, and provides clear answers to how we know Earth is round. You've just unlocked another piece of knowledge with Zentara Unlocked. Craving more? Zentara.blog publishes 6 new, easy-to-digest articles every single day. Don't miss out. Subscribe to the podcast, and we'll catch you on the next one. Stay wonderfully curious.